Hello and welcome. Today is 4th of December 2020 and this is CBSE Class 9 Daily Math video and we are discussing number systems. In today's video, we are going to learn how do we express each of these three decimal numbers in the form of a rational number, that is in the form of P by Q. Each of these numbers we want to write them in the form of P by Q, where P and Q are integers and Q is not equal to 0. So let's find out how do we actually go ahead and solve a question like this. Now we know that there are two unique things about decimal expansions of rational number. What are they? Number one, they terminate. Number two, if in the event they do not terminate, then the decimal expansion, it always repeats. So let's do one thing. Now let's take an example of each of these two scenarios. So let's say we want to divide the number. So we have a rational number like 3 by 4. So what is the decimal expansion of this rational number? Well, the only way to find out is actually to carry out this division, isn't it? So let's do this. So we write here the number 4 and the number 3. 3 is smaller than 4, so we put a decimal. So we get a 0. So 4 times 7 is 28. 38 minus 28 is, so we get 2, and because we have a decimal, so we get a 0. Now 4 times 5 is 20. So 20 minus 20 is 0. So because the remainder is 0, so the division stops, and this is our quotient. So this will basically be equal to 0.75. So the decimal expansion of this rational number is this. So this is an example where the decimal expansion actually terminates. Now let's do one thing. Let's flip the numerator denominator. In that case, what will we get? Let's do it over here. So we will get 4 divided by 3. This is a rational number. So what is this equal to? Let's do this division maybe over here. So we have the number 4 and we want to divide this by 3. So we have, so 3 times 1 is 3. So now we get 1 as remainder. And 1 is smaller than 3. So we put a decimal, so we get 0. Now 3 times 3 is 9. So we subtract 9 from 10, we get 1, and again we get a 0. So again it will be 3 times 3 is 9, and then we do the subtraction, we get again 1. So we see that we keep getting remainder as 1. That means we have to keep going like this. In other words, this decimal expansion will look like 1.333333, so on and so forth. Or we can also write this as 1.3. It is the number 3 which is continuously repeating, so we put a bar above it. So this is an example of a decimal expansion for a rational number where it does not terminate but it repeats. Now let's take a look at our questions and see how do we solve it. So let's get rid of the question marks. Now, can we write this decimal number as 2, 3, 4, 7 divided by how many decimal places does this number have? Well, let's say it has 1, 2, 3. So when we write the number without decimal, so we write the entire number, we divide this by 1, and then how many zeros? Because there are 3 decimal places, we write 3 zeros. Or we can think of it this way, that we write the entire number 2, 3, 4, 7. We divide this by 10 to the power of how many decimal places there are? There are 3, so we put 10 to the power 3. So this is how we express this decimal number in the form of a rational number. Let's take a look at our second question. So let's get rid of the question marks. Now, what does this number mean? So this simply means that it is the 4, 7 that keeps repeating. In other words, we can think of this number as 2.347474747, so on and so forth. It is the number or the block of numbers 4, 7 which continuously repeats forever, right? So how do we actually find out this number in the form of P by Q? So let's assume, let's do it over here. So let's assume that this number is equal to x, meaning 2.3474747 4, 7, 4, 7, 4, 7, so on and so forth. This number is equal to x. Now our goal is to get the decimal as close as possible just before the repeating group of numbers. So here it is the 4747 that repeats. So we want to move the decimal place from here to here. So how do we do that? Well, we simply multiply both sides by 10. So if we multiply both sides by 10, so we times 10 here, that will help move the number. So here on the left side, we will get 10x equal to, if the decimal moves here, so now we will get this number as 23 plus, actually I'm getting ahead of myself. So let's see, it will be 23.474747, like this, right? And this we can write it as, so on the left side we have 10x, and this we can write it as the number 23 plus, here we can write this as 0.474747, so on and so forth. So now we have to figure out what is the value of this. So let's write it over here. So let's say this part is equal to y. In other words, our number, final number looks like 10x equals 23 plus y, where y is equal to this number 0.47. Oh, all right, we should write it as 0.474747, so on and so forth. Now how do we find out this? So what we will do is we are going to again move the decimal to 2 places to the right, because there are 2 digits that keep repeating. So we are going to move it 2 places to the right. So we can do that by multiplying both sides by 100. So if we do that, so here we have 0.474747. We are multiplying both sides by 100. So we get 100y here. This will be equal to, so this will be 47.474747, so on and so forth. And now we can write this as 100y equals 47 plus 0.474747, or 100y equals 47 plus, now what is this? Well, this is just y, right? Because y is equal to this value. So this is y, so we can write it like this. So if we get the y over here, then we will get 99y is equal to 47, or dividing both sides by 99, we will get y equals 47 divided by 99. So now we know the value of y. Y is equal to 47 by 99. So we can simply replace that here, and we will get 10x equals 23 plus 47 by 99. So, or this will be equal to, let's do it over here. So we have 10x equals, now how do we simplify this? Well, the denominator will be 99, and this will be 23 times 99 plus 47, and this will be across the entire thing. And now when we divide both sides by 10, so that will get rid of here, and we'll be left with only x. So x is equal to 23 times 99 plus 47, entire thing divided by 990. Or in other words, this actually will become 23 times 99 plus 47, entire thing by 990. So we have been able to express this decimal expansion as a rational number, which it can be expressed in the form of p by q. So I know this is a fairly complex question, but I wanted to take a look at the complex question and not take a look at one of the easier examples. Now let's quickly review the last part, or the last question in this video. So how do we actually represent this number? Now the bar is only on top of number 7. So how can we represent this in the form of p by q? Well, we will take the exact same approach what we did in the last example. So we will assume that let's say it is x, that is x is equal to 2.347 bar. Now what this means, we just talked about it, that means that x is equal to 2.34, it is the number 7 that is repeating. So this is how a decimal expansion looks like. So if we do it this way, now our goal is to move the decimal just before where the block of or group of numbers that repeats, it starts. So we have to move it 2 decimal places to the right. So how do we do that? We multiply both sides by 100. So we get 100x, which will be 2.34777 times 100. This will help us move the decimal over here, right? So we will get 100x will be equal to 234.777 like this, which we can write it as 100x equals 234 plus 0.777 like that. And now we want to find out what is this. So let's do it over here. So let's say this value is y. So y is equal to 0.7777 like that. So because there is only one number which is repeating, we want to move the decimal place one place to the right side. So we multiply both sides by 10. So we get 10y is equal to 7.777 like this. So once the decimal place moves one place to the right, we get 7 point like that. Or we can write it as 10y equals 7 plus 0.7777 dot dot dot. Now this is nothing but the number y, right? So we can write this as 10y equals 7 plus y. So we move the y on this side. So we will get 9y equals 7. So dividing both sides by 9, we get y equals 7 over 9. So we know y is equal to 7 over 9. So that means we can simply plug this is y. So we can write here 100x equals 234 plus 7 over 9. And we can write this as 100x equals, so if we simplify this, we'll get 9 in the denominator. We will get 234 times 9 plus 7. And then we divide both sides by 100 to actually cancel off here. So this we'll get 900. In other words, this expansion, or this in the rational number form will look like 234. So we have 234 times 9 plus 7, entire thing divided by 900. So I'm not going ahead and fully solving it, but you see how when we actually solve, we definitely can get this in the form of a p by q. So this is how we solve these type of problems.